All right, our final lesson for this unit is the cosine law. Once again, it's a review of things that you did last year, but this lesson will serve as a memory refresher, and maybe you'll even pick up on a couple things that you didn't know from last year. All right, so before we begin, let's recall when to use the sine law, because you're going to be, your challenge, I suppose, is based on the question that's given to you, you're going to have to know whether to use the sine law or to use the cosine law. By the way, the cosine law, if you go to my website, there's a link to a derivation of where the cosine law formula comes from. I'm not going to spend any time in this lesson discussing that. So if you want to see that, by all means, go take a look on my site. But let's recap. When do you use the sine law? All right. When, if you remember, it is when you have an angle and opposite side length plus an angle, or another angle, we should say, another angle given. All right. And also when you have an angle and an opposite side length and another side length given. So you're always looking for that opposite angle side length, right? When you do have that, that's given, there's a high probability or there's a great chance that you're going to be using the sine law. And then I'd say that pretty much every other scenario, you're looking to use the cosine law, okay? But we'll take a look at when exactly to use the cosine law. All right, so to solve oblique triangles that don't meet those criteria above, we can use the sine law. All right. In order to use the cosine law. In order to use the cosine law, there's two situations when you need to use it. All right, and I will show you those two situations right now. So suppose we are given angle B. So I'll call it theta. We're given angle B. And we're given angle A. So this is given, and we're given, side A, and we're given side length C. All right, so when we have this situation where we have what's called a contained angle, this is called a contained angle. Why is it called a contained angle? Well, we have an angle that's given to us, and it's kind of sandwiched between two side lengths that are given as well. So here, here, and here. That's called side angle side, by the way. That's just another way to call it. But it's a contained angle. That's one time that you use cosine law. The other time is very easy. So if I were to draw another triangle here, and I were to call it ABC again, okay? The other time that you use the sine law is if all three side lengths, the cosine law, if all three side lengths are given to you. So let's say this was given, and this was given. Okay, that's called side, side, side. Then you also use the cosine law. Pretty much every other time you're going to use the sine law. So let's summarize there. When we have a contained angle, bracket sine angle side, or when all side lengths are given, that's called side, side, side. All right, so let's put this into practice. I mean, we've got our cosine law formula, which is the following. C squared equals A squared plus B squared. So it looks like Pythagorean theorem. But then it's got this additional part to it where it's minus 2 times A times B times the cos of angle C. Here is your cosine law formula. A couple things to note. This formula right now, as it stands, solves for angle C, right? For side length C. And if you notice, whatever lowercase letter you have here, it needs to correspond with the uppercase letter you have here. For example, let's say ABC isn't used in the triangle and you have DEF instead, and you're solving for side length D. So you were to have, let's say, lowercase d on the left. That means you have to have capital D all the way there on the right. So depending on what you're solving for, what side length you're solving for, you have to have the angle that corresponds with it on the far end of your formula there. And then if you notice, the a squared plus b squared will match with the a times b that's there. Okay, so it's your other two sides of the triangle. But let's look at what that looks like into practice rather than talking about it. Here's an example where we have a contained angle. So it's an angle sandwiched by two side lengths. So we have side, angle, side, which is the cosine law. First thing you're going to do is you're going to label this triangle. And I'm purposely not going to use the letters A, B, C because I want us to be able to adapt regardless of the letters here. So if this is lowercase x, I'll call this capital X. I'll call this capital Y and then capital Z. Here will be my lowercase y and here will be my lowercase z. Okay? So step one is always label your triangle accordingly. All right, I purposely use different letters here from A, B, and C so that we can see how to handle a situation like that. So we are solving for side length C, correct? So I'm going to put, side length X. So instead of putting C squared on the left, I'm going to put X squared because that's what I'm solving for. Then I'm going to put my other two variables here, write out my minus 2. Now, instead of A times B, you look at your variables that you put here. It's Y times Z. Okay, these have to match up right here. These variables have to match up. Then times the cosine of the capital or the angle that corresponds with what you're solving for. So cos of capital X. Okay, so recap that. If we're solving for x squared, it should line up with my capital X on the right, and I put my other two side lengths in these positions here. Okay? And now we simply fill in our information. So we have x squared, which we're solving for, is equal to lowercase y, which is 12 squared plus 10 squared minus. Now put everything in brackets because it's all multiplication. 2 times 12 times 10 times the cosine of angle x, which is 62 degrees. So it's all multiplication. So what we're going to do then is, well, I can figure out 12 squared plus 10 squared. That's simple enough. Okay, so 12 squared is 144 plus 10 squared is 100. So I have 244. Bring down your minus sign. And now do your entire multiplication there. So 2 times 12 times 10 times cos 62. Okay? And I would always round that value there to about 4 decimal places. You end up with 112.4732. All right, now you just subtract those two numbers. Okay? Right there, and that's not your final answer. Be careful. Remember that you've got to get x by itself, so you have to square root 131.33, and x equals, I'm going to put 11. Notice I'm not going to use any decimal places because the question didn't tell me not to use any didn't tell me otherwise, and so then that means I look, does the question have any decimal places within it? And that's kind of the standard of the accuracy that you would use, right? So because there's no decimal places in the question itself and there was no instructions on it, I'm just going to round to the nearest whole number just like was written in the triangle. There's no units there either. Next situation, split that down there, is we have a triangle where we have to check to see if we use the cosine law, and we are given all three side lengths. So yes, we use the cosine law. Okay, simple enough. And we need to solve for theta. So we need to solve for angle B. All right, so we're in this triangle, it's ABC, it's already labeled for us, and we're solving for angle B. That means you need to have cos B on the far right, and you need to have B squared, side length B, which is this. Label your triangle, by the way. Because you're solving for angle B, you have to have lowercase b squared on the left there. Okay, those have to correspond. And now fill in the rest. It goes a squared plus c squared minus 2 times a times c times the cos of angle B. Okay, notice again, match up, and my a and my c match up with my a and my c there. And now fill in all your values. This time we are given side length B, so we know that this is 15.2 squared, is equal to A, which is 11.6 squared, plus C, which is 7.4 squared. And this is bad form by me. You should always substitute numbers. You should always use brackets when you substitute numbers in, okay? Bring down your minus sign, put your 2 in brackets, put your A in brackets, your C in brackets, and then put your cos of angle B. Now, we don't know B, but put that also in brackets. But we don't know B. All right, that's what we're going to end up solving for. So we're going to do some BEDMAS here, some math, some quick math in our calculator, and eventually we're going to get angle B by itself. So let's start on the left. We've got 15.2 squared. Okay, is 231.04 equals 11.6 squared. Okay, is 134.56 plus 7.4 squared. Okay, is 54.76. Now, bring down your minus sign, and let's actually multiply 2 times 11.6 times 7.4. Okay, so 2 times 11.6 times 7.4. That is 171.68 times the cos of B. Okay, don't forget that it's times the cos of B. We're ready to start. Actually, let's clean this up. Why not? We can add these together. Can we subtract this number minus this number? No. Because it's times the cos of B, we can't touch that 171.68 yet. All right, we can't do anything with that. So let's just take our time here and let's add those first two numbers of 134.56 plus 54.76. You end up with 189.32. Okay? Now let's start to bring some numbers over. Once again, I can't do anything with this right now because it's being multiplied by cos B. But I can bring over this constant by subtracting it on the left. So you end up getting 231.04 minus 189.32 equals negative 171.68 times the cos of B. Okay, so 231.04 minus 189.32, you end up getting 41.72. Okay, now how do we start to get B by itself? Well, it's being multiplied by negative 178.68, so divide it on the other side. Now, I'm going to do two steps here, okay? So instead of writing cos B here, I know I'm going to have to bring the cos to the other side as well. So I'm just going to write the cos inverse of this number equals B. That just saves me some space because I'm running out of space. Okay? So, second function, cos, open a bracket, 41.72 divided by negative 171.68, close your bracket, hit equals, and you get 104.1 degree. Go back and see if that makes sense, right? If you look at the way this triangle is drawn, this must be an angle greater than 90. It looks like it's bigger than 90. So having an angle of 104.1 makes perfect sense. You might ask, why did I use one decimal place? I just looked in the question and I noticed that in the question they have used one decimal place. So I'm also going to do that in my answer. Okay? This takes practice. There's a lot of little spots where you can go wrong. Okay, so you can definitely accidentally in this step here add and then subtract negative 171.68. That's the most common mistake. You can't do that. You've got to leave that negative 171.68 or minus 171.68. Leave it where it is. You're going to have to divide that out eventually, but you're not subtracting it. Okay. For the next two problems, we've got some word problems. So we're going to have to draw a diagram. Okay, so let's try to draw a nice, neat diagram that will help us solve what we've got going on here, what we're being asked of. So a boat travels 60 kilometers due east. Okay, so it's going straight east 60 kilometers. Then it adjusts its course by 25 degrees northward. Okay, by 25 degrees northward, okay, and travels another 90 kilometers in this new direction. So let's think what that means. At this point, you travel 25 degrees towards the north. So with this horizontal here, you're going to be traveling 25 degrees. So approximately this would be 25 degrees, okay? And you're doing that for 90 kilometers, so a longer line than the first line. You can see now how our triangle will be formed. Okay, so our triangle is going to look something like this. This is a pretty tricky part here, right? Being able to know that northward 25 degrees means you're turning towards the north by 25 degrees. Okay? If you know this angle here, can you find this angle here? Well, the two angles there, they're supplementary angles, and we know that supplementary angles should add up to 180. So that angle in there should actually be 180 minus 25, okay, which is 155. So we actually know that angle. And now what do we have, right? We've got a contained angle, side situation. Let's label our triangle. I'll call this A, B, and C, which makes lowercase a right there, lowercase c right here, and lowercase b right here. It says, how far is the boat from its initial position? Well, here's its initial position. Currently, the boat is here, so we are solving for side length B. Okay, no problem. So we're going to set up our formula. Notice my lowercase b corresponds with my angle on the far right. My other two side lengths correspond with my A and C being multiplied by 2 and times cos angle B as well. So you end up getting, when we substitute our values in brackets, put your 2 in brackets, put your 90 in brackets, put your 60 in brackets, put your cos times angle B, which is 155 in brackets, okay? So that you know that you're multiplying all of this together. We can add 90 squared plus 60 squared, okay? So we can do that pretty easily on our calculator. It's 11,700. Bring down your minus sign. and now do 2 times 90 times 60 times the cos of 155. And you actually end up with a negative number there. And that makes sense because the cos of 155, if we remember, 155 degrees is in the second quadrant, and we know that cos ratios are negative in the second quadrant. So we're actually going to get a negative number. We're going to get negative 9,788.1241. I'll carry those 4 decimals there. At this point, you have to recognize that you have a double negative there that we're going to turn into addition. Okay. What does that equal? 1700 plus 9788.1241. You end up getting 11,700. My mistake. Okay, my mistake. That's 11,700 plus 9788.1241. That's 21,000, right? That makes more sense. 488.1241. Take the square root now of that number. And you get, okay, so square root 21488.1241. You get 146 to the nearest kilometer. We actually have to round up because it's 146.6. So we're going to go to 147 kilometers. Okay, that's how far apart you are from the starting position. Okay, so that's solving for a side. Let's look at our next question, okay, where we're going to be solving for an angle. So it says the posts of a hockey net are 1.8 meters apart. So here we have a hockey net. From here to here is 1.8 meters. Okay, a player tries to score a goal by shooting the puck along the ice from a point that is 4.3 meters from one goal post and 4 meters from the other. So somewhere here, someone is trying to shoot the puck 4.3 meters from one goal post, 4 meters to the other goal post. Okay. And we're asked, what angle does the player have to shoot within to score? So we're looking, what angle does the player have to shoot within, which is here, in order to score. So let's label our triangle A, B, C. You can see that we're given all 3 side lengths, which is a side, side, side scenario, which tells me it's cosine law. If angle A is here, then lowercase a is here, lowercase b there, and lowercase c. Let's set up our equation, our formula. Since we're solving for angle A, we have to have cos of angle A on the far right, which means we have to have lowercase a on the far left. Okay? Let's fill in our values. 1.8 squared equals 4.3 squared plus 4.0 squared minus, put everything in brackets, okay, but we don't know capital A. That's what we're going to end up solving for. No problem. We can obviously clean up all of our exponents, and then we can even multiply these 3 numbers together and just bring down our minus sign. So let's go 1.8 squared is 3.24. 4.3 squared is 18.49. Plus 4.0 squared is 16.0. Bring down the minus sign, and now let's do 2 times 4.3 times 4. Be careful here. You cannot subtract the 34.4. It's being multiplied by cos A, right? But we can combine these two, so we end up with 3.24 is equal to 18.49 plus 16. Again, be careful. You cannot subtract the 34.4. We're going to move this over to the other side. So we're going to end up with 3.24 minus 34.49 minus on the other side. And you're going to end up with a negative number here. And don't be alarmed. That's okay, because we have a negative number here, right? On the right side as well. And now we're going to remove the negative 34.4 by dividing it out. And I'm going to save a step. I'm going to take the cos inverse. I'm going to just write it on the left. Is equal to angle A. So now you press second function cos, right? Second function cos, open a bracket, negative 31.25 divided by negative 34.4. Okay. Okay, your answer. And now it says, it doesn't say anything about to the nearest degree, okay, but we have one decimal place in our diagram, so we're going to do one decimal place for our angle as well. It's 24.7 degrees. So if this hockey player shoots within an angle of 24.7 degrees and doesn't shoot it too high, of course, then this hockey player will be hitting the net. Okay, so that concludes what we did in this lesson. I showed you how to solve for a side as well as an angle. We did a word problem for each. The hard part for you is going to be knowing how to draw the diagram, interpreting the question and knowing how to draw the diagram. And all I can tell you that will make you good at this is practice, practice, practice. As many word problems as you can see and look at, practice drawing the diagrams. And then after so many times, you'll have pretty much seen every situation and you'll know what to do.